Imagine waking up one morning, gazing out over the horizon, and realizing that something monumental has changed. The vast stretches of blue that once held the world's oceans are still there, sparkling under the sun. But they are different now. The salt that gave the oceans their briny taste and buoyant feel has vanished. Everywhere, from the deepest trenches to the widest bays, from the swirling waters of the Antarctic to the balmy Caribbean, all the planet's seawater has become fresh water. Such a transformation would undoubtedly be the single most dramatic shift our planet has ever experienced. A rewriting of natural laws, a crisis, and an opportunity rolled into one. As the implications begin to ripple outwards, we find ourselves standing on the edge of a new world, a planet profoundly changed in ways both wondrous and catastrophic. To understand what such a change would mean, we must first consider what makes seawater special. The salty tang you taste when you leap into the surf, what we call salinity, averages about 35 grams of dissolved salts per liter. These salts, primarily sodium chloride, but also magnesium, calcium, potassium, and others, were carried into the oceans by rivers eons ago, gradually accumulating until life itself adapted to their presence. The sea's saltiness influences everything from ocean currents to weather, from the balance of carbon dioxide to the survival of species. It is the bedrock upon which marine life has flourished. With one miraculous sweep, the salt has vanished. The oceans are now fresh, and nothing will ever be the same. First, the marine organisms. Life in the ocean is adapted to seawater's recipe. Microscopic phytoplankton, crustaceans, fish, whales, all have evolved cells and bodily fluids in precise balance with the brine surrounding them. Remove the salt, and almost every marine species is sentenced to a slow demise. Fish would find it difficult or impossible to regulate the water and nutrient flow in and out of their bodies, succumbing to dehydration or swelling. The great coral reefs, those underwater rainforests built from calcium-hungry polyps, would wither and dissolve. Only a handful of hardy species designed for the variable waters of river mouths and coastal inlets, creatures like salmon and certain shellfish, might limp on for a time, but the vastness of the blue world suddenly becomes a graveyard. Next, the ocean itself. Salt gives seawater its particular density, the reason icebergs float, why ships ride so high on the waves, why some swimmers notice more buoyancy in the Dead Sea than the Pacific. Without salt, density drops, and the dynamics of the world's water bodies change. Ships would ride lower, cargo calculations would shift, and safe voyage would become a more complicated affair. Nautical traditions honed over millennia would be scrambled overnight. More profoundly, the loss of salt destroys the conveyor belt of ocean currents. These are the rivers within oceans, driven largely by differences in temperature and salinity, a process called thermohaline circulation. Warm, salty water moves near the surface. Cold, less salty water sinks and flows along the deep ocean floor. This majestic dance regulates the world's climate, keeping Europe temperate, balancing monsoons, and driving the migration of nutrients and marine animals. Without salinity gradients, the ocean's currents slow and stall. The Great Gulf Stream, which brings warmth from the Gulf of Mexico to the chilly shores of the United Kingdom, dissipates. Tropical waters lose their upward surge of nutrients, stifling the productivity that supports fisheries and food webs. Regions dependent upon steady currents for their weather, places like Western Europe, India, and North America, find their climates veering off course, sometimes warming, sometimes chilling, always unpredictable. Wind patterns, too, begin to shift. The interconnectedness of ocean and atmosphere is seamless and complex. Evaporation from the now saltless sea becomes easier, for pure water evaporates more quickly than salt water. More water vapor rises into the atmosphere, potentially fueling massive storms, altering precipitation, and increasing humidity worldwide. Some areas would experience deluges never seen before. Others might paradoxically dry out as winds redirect storm tracks elsewhere. As the salt disappears, the very chemistry of the water changes. Salt is a buffer. It helps regulate the acidity of the sea, balancing the absorption and release of carbon dioxide from the atmosphere. Fresh water absorbs and releases CO2 differently, which could cause the global carbon cycle to spiral out of control. Oceans currently absorb 1/4 of the carbon dioxide emitted by human activity. With the sudden switch to fresh water, their role as a carbon sink could falter. Atmospheric CO2 levels might spike, intensifying global warming and erasing the ocean's current mitigating effect. The consequences for weather are enormous. Storms draw their strength from the contrast between hot and cold, moist and dry, salt and fresh. With the evaporation rate now elevated, hurricanes and typhoons could grow more ferocious and frequent. Rainfall patterns would be utterly upended. In some regions, monsoons might become overwhelming torrents, while deserts might bloom with unseasonal rains. If there's one place on Earth that would feel the effects instantly, it's the polar ice caps. Salt helps seawater freeze at lower temperatures. Fresh water freezes more readily. As the entire ocean becomes unsalted, polar waters would ice over more quickly and more uniformly. Sea ice would expand, reflecting sunlight back into space and potentially moderating global temperatures, at least for a while. But that doesn't guarantee a return to stability. All the salt that used to float in solution in the oceans would now be missing. Not gone, just displaced or precipitated in ways we haven't seen before. Salt deposits might appear on the seafloor, wiped away by tides, or settle in enormous clouds in the atmosphere. The geologic cycle would be thrown into turmoil as rivers continued to erode rocks and carry new salts to the sea. But with nowhere for that salt to go, except to remingle and slowly restore the briny balance over many thousands of years. Fresh water is a precious resource on land. For billions, the great quest of every day is to find enough of it to drink, cook, and irrigate. The sudden transformation of the world's oceans into immense basins of potable liquid would seem, at first, to be a blessing. But this, too, is a double-edged sword. Desalination plants, enormous and energy-hungry, would now be useless. Regions once limited by water scarcity, North Africa, the Middle East, the California coast, might imagine themselves at the dawn of easy abundance. But the fresh water of the ocean is not so easy to harvest. The infrastructure required to extract, purify, and transport this new bounty would take generations to build. More troublingly, the loss of salt water means the loss of a vital barrier. Rivers currently flow into the sea, delivering not just water, but sediment, nutrients, and pollutants. Salt water resists the flow, creating the rich, diverse estuaries where life flourishes, and where pollutants are often filtered out before reaching the deep. With only fresh water in play, rivers blend seamlessly with the sea, flushing their contents across the oceans unopposed. Nutrient runoffs could spread undiluted, feeding algal blooms that choke life from entire regions. Oil spills, agricultural chemicals, and sewage could travel farther, affecting coastlines thousands of miles away. Tides roll on, of course, driven not by salt, but by the moon's gravity. Yet even here, there is unseen havoc. Salt water's mass and density add to the momentum of tides and waves. Now they are a little weaker, a little less forceful as they crash against the shore. Erosion rates might change. The balance of sandy beaches and rocky cliffs could tip, rearranging coastlines over time. Consider, too, the direct economic impacts. Fisheries, once the lifeblood of coastal communities, would dwindle and collapse as their stock died off. Entire nations would lose a source of protein, employment, culture, and identity. Fleets and processing factories would fall silent. Chain reactions would ripple from boatyards to supermarkets, from family-owned markets to international conglomerates. Tourism would shift in ways both subtle and stark. Scuba diving among reefs would become pointless, the vibrant colors and bustling life gone, only silent monuments in their place. Beachgoers would lose that peculiar floaty feeling, sinking lower in the water. The joy of surfing saline waves, the bracing slap of cold brine on tanned skin, would be replaced by an odd sense of something missing. But perhaps the biggest crisis would be invisible, lurking in the narrow margins that support all life. Oxygen. The ocean is Earth's greatest oxygen factory. Through photosynthesis, plankton churn out more than 50% of the oxygen we breathe. Yet these organisms, too, require salt. As they falter and perish, the global supply of breathable air would slowly diminish. Humanity might not notice in the first months or even years, but eventually, the world would yearn for air with the same desperation it once reserved for water. If we look further, the fragility of our interconnected systems becomes even more evident. Agricultural cycles, industrial supply chains, shipping lanes, global health all depend upon an unspoken assumption that the oceans are, and will remain, vast, salty, and stable. With that gone, unexpected crises emerge. Certain minerals extracted from the deep, including magnesium and bromine, are harvested from briny depths. Their supply would halt. Seawater is a source, too, of rare gases and trace elements. Industries built upon its constancy would face shortages, disruptions, and economic disarray. Some may dream of using this newfound freshwater to irrigate deserts, to green Sahara or Gobi, to generate unlimited hydroelectric power, or fill the world's reservoirs. Yet the technological and ecological infrastructure required to harness such a resource is far beyond what humanity possesses. Even if oil tankers and pipelines and aqueducts were repurposed overnight, moving billions of tons of water from sea to land would create fresh dilemmas. Salt left behind in soils, new patterns of erosion and flooding, and the unintended consequences of disrupting local climates. The change would also reach into the invisible molecular world where life began. The genetic makeup of all marine creatures is intertwined with the chemistry of their surroundings. Remove salt, and we erase not just a habitat, but a crucible. Some scientists speculate that life itself first sparked in salty primordial oceans. A freshwater ocean might dampen the processes that gave birth, billions of years ago, to the miracle of evolution. Human history, culture, and myth are all wrapped around the world's oceans. Languages are shaped by the tides, religions hint at the purifying, mysterious properties of salt and sea, and economies have risen and fallen according to the ocean's gifts. Would we write new myths for our freshwater seas, or would we persist in remembering the old glory days when sailors braved the briny blue? Environmental and societal adaptation would become the grand project of the next centuries. Governments and scientists would race to invent new ways to feed the world, harness the changed oceans, and restore what was lost. The scale of the problem is so vast that international cooperation would be required, perhaps on a scale never before seen. Rival nations drawn together by a crisis beyond politics or geography. Children born in this new world would never taste the sting of salt on their lips as they swim. The word ocean would conjure a sense not of mystery but of loss, a reminder of the intricate web of natural laws that, once broken, cannot easily be repaired. Yet, as always, life is tenacious. Given time, evolution could tweak and transform. New species would emerge, adapted to fresh water's different chemistry and opportunities. The seas would fill once more with living wonders, though in forms we cannot imagine. For now, let us step back and watch as the world reorganizes itself in response. Birds that once soared over the sea in search of fish would fly on, confused, hungry, lost. Whales, stripped of their plankton-rich banquets, would migrate along old routes to find them barren. The haunting whale song echoing through the water would become a requiem. Millions upon millions of humans would adapt, as humans always do. Coastal communities would perhaps look to farming the rich new mudflats where estuaries once mingled salt and fresh. New industries would arise, perhaps using technologies to reintroduce salt, or to farm freshwater-adapted fish on an industrial scale. The great question would hang in the air: could salt, having vanished, be restored? With patience, rivers would trickle in, delivering grains of sodium, magnesium, and calcium to the shores. Decade by decade, the oceans would edge back toward their ancient composition. But this is a slow process, measured in human lifetimes or more. In the meantime, all the creatures and cycles that depended on salt would have perished, and the surface of things would look far different. The planet itself would be forever marked. The cycles of rain and drought, the hexagons of snowflakes, and the shimmer of dew, the taste of tears, and the invisible balance of internal chemistry in every living cell all are tied to the balance of salt and water, fresh and briny. By altering the greatest repository of salt on Earth, we would have not merely changed the face of the globe, we would have rewritten the rules of life itself. In the end, the notion of a freshwater ocean is both miraculous and terrifying. It reveals the delicate chains of connection that bind us all, the razor-thin line upon which balance is maintained. The salt in the sea, so easily overlooked, is the reason for ocean currents, for climates, for living reefs and coral atolls, for the air we breathe and the food we eat. Should we one day look out upon a freshwater sea, unsalted, unfamiliar, and new, we would understand more deeply the intricate, wondrous complexity of nature. Our planet, shaped over eons by tiny increments of chemistry, would become a stranger to us all. And as we adapt to this new reality, we would be left to ponder how every small thing, every grain of salt, plays a part in the staggering drama of life on Earth.